Hi, in this video, let's talk about another two of the most popular interview questions, coding interview questions. One of them is called Fibonacci sequence, and the second of them is called the Pascal Triangle. I hope I pronounced the name correctly. But anyways, the correct way to solve this problem is to use probably recursion plus memoization. So let's get to it. And you cannot miss the memoization part because it's going to give you a huge performance boost. So let's write our solution. So first, let's write the function without the memoization, and let's prove to ourselves why we need memoization to have the solution with it. So first, let's declare a base case for our recursive method. So if n is smaller or equals to 1, then we return our n. And okay, so else we just return fab at n minus 1 plus fab at n minus 2. And we have our solution. Pretty straightforward, right? And we just need to console.log fab and the value is probably 7 to get our solution. So alright, but why we need memoization? Let me show you what does it mean. So console.log and let's say fab and let's try to run this function again. You can see that we are recalculating the result of fab3 multiple times, and so does fab4 and fab2. Fab2 probably is the one that show up the most. So we have keep recalculating the result of a value that we have calculated before. So what if we put the value that we calculated before in somewhere and use it directly, so that we can save a lot of time and space. So that's called memoization basically. So, but before we do that, just let's give another more solid example so that we can visualize the improvements. Alright, so fab50 using the old code would look something like this. You see the function is kept running and running and running, and it takes a lot of time and uses a lot of space. So let's now wait for the result. So what if we just put a memo here? Memo stands for memoization, and let's initialize it with a new map. So the map is going to be fast, the super fast one, but it has a limit of the size. Unlike array accept a bigger size, but map is compared to array accept less sets. So just keep that in mind, and we can then say, so if our memo has a key, which is using the value of n, if that's the case, we just return our memo get the key. Else we say memo that set, we set the value first, so fab, okay, using n as the key first, then we say fab in minus 1 passing the memo plus fab in minus 2 passing the memo. After that we just need to return memo dot get, yes, and let's say n. So we just set the n as the key, so we don't need to check if we has this key of n anymore. All right, so let's rerun our solution. As you can see, we almost immediately get our solution. Okay, probably not 13. Probably we are testing 7. As you can see, our solution is 13. So let's put this code onto the LeetCode and see what kind of result we are getting. All right. Let's submit our solution. As you can see, it's almost guaranteed that we have a solution that's going to be faster 100% than most submissions and use less memory usage than almost 100 of online submissions. So that's the power of memoization. As you can see, I have tested this solution multiple times. And so the best way is not to just declare another placeholder, call in the result, and pass this value inside result and use the set. Just because we are using a hash map, so getting the value is nearly the time of O of n, so O of 1, and so that's good enough. So let's move on to the second one, Pascal Triangle, and see how we can calculate the solution for that as well. Come up with a good solution for that as well. So Pascal Triangle is also a sequence that, let's say, the base case would be given a number of levels. So let's say level 1, level 2, level 3. We have the same number of elements as the level number. So level 3 has 3 elements, and level 4 has 4 elements, and etc. And the side element will always be 1. That's one thing to note. And the values within equals to the values above. That's and the sum of it is, so in a certain way it's a lot like Fibonacci sequence, but just 2D one. So 3 is equals to 1 plus 2, and this 3 equals to 1 plus 2. So this is, so let's say this is column 2, 0, 1, 2, and the first value to sum it up is the level above, and same column number 3 and number 2 and column 1, and add them together. So without further ado, let's write our solution. It's basically the same as our Fibonacci solution, but there's a super catch. So let's write this. So super important thing pending, important thing to note about hash map. Let's later review the solution. So let's write this the simple way first. Function. It's also going to be a 2-line solution, by the way. So Pascal at index. So it's going to be having 2 numbers. So first is the row number, second is the column number. So if we want to have a value at index of a certain place, so we need 2 numbers. So let's discuss the base case first. So if our column number is equals to 0, or so why we use, okay, for example, in row number we'll use 1, 2, 3, 4, 5, but for column number we'll use 0, 1, 2, 3, 4, because as you can see here, it's an array. When it's array, we can, the best way, it's super easy if we just use the index at the array to refer to their column number. And it's less likely to make mistakes this way for myself. All right, and column number is equals to 0. And other case is here. So 0 is first element, second element, the side will be the last element of the array. So column num. Okay, let's use triple equal here. Triple equal here as well. And equals to what? To row number. Row number minus 1. let's say level 5, 5 elements, last index 4. Okay, return 1. Or otherwise, we just return Pascal and let's take in the row number -1 and have the column number plus the same value but having column number -1. We'll have our result. So console.log, let's test our solution. Pascal at level 5, index 0, 1, 2, 6. Okay, let's test our solution. As you can see, we get 6, and if we move on, it's going to be 4. Great, we have our solution. But this, just like memoization, is keep calculating the same. I will not write the same code again, but we keep calculating the same result over and over again. And we don't want that. We want to implement memoization in this case. So normally, as you can see, we have two values. Some may want to use a key like what do we call it? An object. And let's see how it works out first. So that's the biggest catch, because even it looks like object works, but inside the sequence is actually not. So let me show you what does it mean. So constant key equals to object, right? First thing first, row number takes in the row number, and column number takes in the column number, right? And just the same thing as we did in here. If our, okay, let's declare the memo first. So basically it's the same implementation. So do not feel okay. So here memo dot has key. We just put key here. Then we just return memo dot get key. Right. Else, I think we will just say memo.set, okay, key, and use the case we find here and pass in the memo, I assume. Delete this row and we say return memo.get key for key. And let's test our solution. So it's going to give us the same result, alright? And by the appearance of it, we are not writing a wrong solution, but let's just test it out. So let's console.log 1. If we have something here, so we just put one key here and console.log 2 and key here. Clear it and rerun the solution. As you can see, all of the recursive function that pass down use the second block to execute them, and we are recalculating the key of having value of rows 3, columns 1 twice. So why is that? Because in a hash map in JavaScript, we cannot use object as key and expect of one if we do not have the same reference to the original object. So imagine this: just when you try to check if memo has a key, if the key is object, we don't include it doesn't expect us to just need to put in value that object has the same value as the object we are checking, the key. It's expecting the original key. So the only way we can use the key or solver key, the object, is that we pass down this key reference every time we run this recursion. But that's impossible because each recursion we are going to define a new key. And if we store these different keys and use them one by one, that's going to even slow the function even more. So that's why we cannot use this solution, having a key that equals to object. So that's one of the most important thing to note, because in the appearance, we might see that there is a problem, but there is one. So it's an important thing to note. Use object as the key. All right. So what we can do, just like we did in here, we either pass in a number or we pass a string. And there's not much choice here. Array also will occur the same problem as object, by the way. So a simple solution here would be having a row. If we do not use key in any circumstances, I suggest you, write a hash function. So let's not write a hash function. Let's just declare a row. I think in this case would be a string. In this case would be enough. So row number, column number would be enough. So in here, let's rerun this function. As you can see, when we find the duplicate one, we have our row 3, column 1, using the first block of code. So that's the solution we are looking for. And we have our solution for Pascal add. But in our LeetCode example here, it's actually expecting us to return this number of using number of rows and calculate the whole array. So basically, what he wants us to just calculate this array. So if we have this function, so let's use this opportunity to declare another way that we can even use memoization. So in another case, so it's going to be a simple implementation. So bear with me, all right? So let's just say function generate Pascal triangle, and takes in a number. So it's going to be okay. So yeah, let's just use it. And all right, and what we want here is that for row, okay, for let, so we need first a result array, okay, and let's initialize it with an empty array, and we also need a memo, and let's initialize it. So if we declare memo here, you can imagine that using the recursive, we'll keep filling the memo in here and using our recursive method. Therefore, we are going to save a lot of memory usage. And so let's be more explicit here. So that row number equals to 0. Row number should be smaller than n. Row number plus plus. So in fact, because we have to retain the row number, let's use something like this instead. Because we need to retain the row number as the function we used here. Okay, so let row array equals to. So it's very intuitive once we have these sub functions, finished. And for another for loop, for let Okay, column number equals to 0 first, column number smaller than our row number, just like what we have here. We can then say row array dot push. Push what? Push the result of our Pascal add. And we just need to pass in the row number here and the column number. And most importantly, our memo here. So it's going to be the same reference is going to be used over and over again. Therefore, we are never going to recalculate the same key, which is super great. Okay, so, yeah. And after this for loop is done, we can say result array should then push the row array, and in the end we return result array. Great, we are finished. So let's test our solution. Okay, let's use the same example as here. So let's get rid of the console log. Is there another console log? Okay, no. Voila, as you can see, compared to the original one, it's correct. So let's take this solution to the LeetCode and see how it performs. So yes, Pascal add should be returned the same thing before. Let's replace it with and let's this make Pascal add the variable so that the interpreter will run it dynamically instead of a in pre-C. So I think it's going to improve the solution a little bit if we write it this way. Okay. So, as you can see, we are faster nearly half the JavaScript online summations, and we are using less memory storage than 100% of the JavaScript online summations. And believe me, the longer, the bigger the number we are using, the faster we are going to be comparing to other JavaScript online summations. So, this is typically how we can write a solution for Fibonacci sequence and Pascal triangle in JavaScript. I hope you like it, and if you have found a better solution, please don't hesitate and paste it on the comments. Let me see so that we can, improve together. Thank you for watching.